we can give a precise definition of a list using the idea of recursion, just like for functions. A list is either an empty list or a pair of an element and another list. This definition is recursive because the word list appears both in the head and in the body of the definition. So I'm defining lists in terms of lists. This is a circular definition. It's not a problem because the list in the body will always be smaller than the list in the head. So we will define a list in terms of a smaller list and so forth until we define the empty list, and there it stops. So this is the same idea that recursive functions use to avoid infinite executions. Here we will avoid the idea of data structures that are infinite in size. So we can define a notation for this. Let me bring in a slide here. Syntax definition of a list. We have list T is defined as either nil or an element of type T followed by a vertical bar followed by a list of type T. Okay, this way of defining syntax is called a formal grammar. This particular form of grammar, the example that I'm showing here, is called EBNF, which stands for Extended Backus-Naur Form. So for historical reasons, this was invented by John Backus and Peter Naur, who were two pioneers in programming languages. So EBNF is one of the most popular ways of defining the syntax of a programming language. So in EBNF, a grammar definition contains grammar rules. And each grammar rule, like here, this is one grammar rule, defines the syntax of an entity. See, here I'm defining the syntax of list T, the list of elements of type T. The : equal means is defined as, the left-hand side names the entity that I'm defining, and the right-hand side gives the syntax definition. Okay, so nil represents itself. It's a symbol that represents the letters N-I-L in the list. The vertical bar is an or, so there's two possibilities here, either nil or T represents an element of type T, whatever T is. Here, the vertical bar in quotes represents a vertical bar in the syntax. And here, again, list T represents a list of elements of type T. Okay, you have to be careful here to distinguish the vertical bar by itself and the vertical bar with quotes. The reason why we have to add quotes in the second vertical bar is so that there's no confusion with the first one. The first vertical bar is part of EBNF, and the second vertical bar is part of the syntax we're defining. Okay, so we have to carefully distinguish the two. So using this definition, we can construct lists that are by definition going to be valid lists. So for example, let's take list int, a list whose elements are integers. And the way it works is that we replace this entity here by one of the alternatives on the right-hand side of the grammar rule. So if we do that, for example, assuming now t is int, is integers, we replace the integer by an integer. We have the vertical bar, and we have another list int. So we have replaced list t by the second part of the alternative. And we can continue. So again, we have list int. For example, we replace it by 11 followed by list int again. And we can go on a little bit more. List int. And now let's stop. What that means is, instead of choosing the recursive alternative, we will choose nil, because list int can be nil, and we have come up with a valid definition of a syntax of a list of 3 elements, 10, 11, and 12. Okay? So that's the definition of syntax. Let's be even more precise on what these symbols mean. So let me bring in a little bit another more precise presentation of what the different symbols mean. So int, in the angle brackets, I have said it represents an integer. that's actually still a little bit too vague. What really it represents is the set of all syntactic representations of integers, where the syntax of something is how you write it down as a sequence of characters. And list of int in angle brackets represents the set of all syntactic representations of lists of integers. And the t in the definition represents the set of all syntactic representations of values of type t. We say that t is a type variable. Okay? Now we've introduced, this is a third kind of variable. So don't confuse type variables with identifiers or variables in memory. Type variables exist only in grammar rules. Okay? So the subtlety, let me bring in another diagram to make this idea very concrete. The subtlety here is that we don't want to confuse something and the representation of that thing. So the surrealist painter René Magritte has famously illustrated this with a painting called Ceci n'est pas une pipe. This is not a pipe. And in fact, it's not a pipe. He's correct. He says this is a painting of a pipe. Actually, that's still not correct. It's not the painting of a pipe. It's a digital display of the photograph of a painting of a pipe. Unless he painted a picture of a pipe, but we assume that he painted a real pipe. So that's what this top figure is. The bottom figure is not an integer. It's a digital display of a visual representation of an integer using numeric symbols in base 10. Okay? The actual integer that we're talking about here, it can't be seen. It's sitting inside the computer, inside the microprocessor. It's a particular state of the processor's memory, a particular, usually stable pattern of electrical charges. So, since we can't see that directly, we have to pick a representation that we can see. So we pick the representation that's convenient for us, and that's how we can think about things.